You don't scale event-driven systems. You lose control of them. And the problem is, it doesn't look like a problem when it starts. Everything looks exactly like it's supposed to. Events flow, services react, nothing is tightly coupled. It feels clean, almost too clean. Then something small changes. Someone adds a consumer. A retry policy gets introduced. A timeout shifts just enough to matter. And from that point on, the system is no longer behaving the way you designed it. It's behaving on its own. It usually starts with something that looks harmless. You emit an event. Order created. A few services react. Email, inventory, billing, nothing unusual. Then a new consumer is added. It retries when it fails. That's when things begin to move. Not visibly at first. One event becomes 2, then 4, then 8. And suddenly the system is doing more work than the users are asking for. That's the moment people miss. Because nothing broke. The system is just busier. But what actually changed is this. The system stopped processing events and started generating them. And once that happens, you've lost control of the load. Because the load is no longer external, it's internal. The only way to stop that is to take control of amplification. You don't let events trigger anything that can react freely. You decide where reactions are allowed to happen. You decide who is allowed to emit new events. And more importantly, you accept that not every reaction should create more reactions. Because if every part of the system is allowed to respond and produce, you don't have a design, you have a chain reaction. The next thing that happens is more subtle. You stop understanding what depends on what. Because nothing is calling anything anymore. Everything is just reacting. You change one event, and something breaks. Not where you expected. Somewhere else. Something you didn't even know was listening. That's when people start saying things like, event-driven systems are loosely coupled. They're not. They're tightly coupled. You just can't see it. The dependencies are still there. They've just moved out of the code and into the behavior. So you bring them back into something you can reason about. You treat events like contracts, not messages. Something owned, something versioned, something with consequences. You map who consumes them. You understand what breaks when they change. Because if you can't answer that, you're not making changes. You're taking risks. Then failure enters the system. Something slows down. Maybe a downstream service, maybe a dependency, doesn't matter. Failures appear, and the system does what it was designed to do. It retries, and then everything accelerates. Every service retries independently. The same request gets sent again, and again, and again. The failing part of the system gets hit harder, which slows it down more, which creates more failures, which creates more retries. And now the system isn't recovering. It's amplifying the failure. At that point, retries are no longer helping you. They're working against you. So you take control of them. You stop letting every service decide how and when to retry. You coordinate it, you limit it, you introduce delay, you introduce randomness. You treat retries as load, not as recovery, because that's what they are. And if you don't treat them that way, they will scale faster than your actual traffic. Then you start seeing delay, not failure. Delay. Events are still being processed, just slower. Queues start growing, consumers fall behind. But nothing stops the producers. They keep emitting. Because they don't feel what's happening downstream. There is no signal, no resistance, just accumulation. And this is where systems become dangerous. Because everything still looks like it's working, until the delay becomes failure. So you introduce pressure, you make the system aware of itself, you measure lag, queue depth, processing time, and you act on it. You slow things down, you stop accepting more work, you allow the system to push back, because if it can't, it will absorb pressure until it breaks, and eventually, you lose boundaries. Events move everywhere, across domains, across teams, across contexts that were never meant to be connected. Everything can subscribe, everything can react. And over time, everything becomes dependent on everything else. At that point, there is no isolation left, only a network of reactions. So you put boundaries back, not by removing events, but by controlling where they are allowed to go. You define domains, you restrict visibility, you introduce handoffs, because not every event belongs everywhere, and not every system should react to everything. This is the part that changes how you think about it. Event-driven systems are not about decoupling. They're about behavior, how events propagate, how pressure builds, how reactions amplify over time. If you design for decoupling, you lose control. If you design for behavior, you get it back. Because your system isn't your services. It's not your event bus. It's the flow between them. And if you don't control that flow, you don't control the system. Event-driven systems don't fail because they scale. They fail because no one controls how they behave when they do. And when behavior isn't controlled, they don't scale. They spiral.